In this lesson, we're going to look at the Pythagorean Theorem. The Pythagorean Theorem is used for finding unknown sides in a right-angled triangle. A right-angled triangle is a triangle that has a 90-degree angle within it. That 90 degrees is sometimes represented by this little square in the corner. Now, if you have the three sides of the triangle labeled A, B, and C, the Pythagorean Theorem says that a squared plus b squared is equal to c squared, where a and b are the legs and c is going to be the hypotenuse. In this first example, we're going to solve for the unknown value of the hypotenuse. And so the first thing I suggest doing is always labeling the triangle until you're comfortable with it, A, B, and C. Start off with the hypotenuse. It is the most important side, and so x is going to be the C, and then 5 and 12 are going to be A and B. Now, it doesn't matter which one you label A and which one you label B. The two legs are interchangeable. So copying down the Pythagorean Theorem formula, a squared plus b squared is equal to c squared, and then subbing in our values of a, b, and c into this equation, I will generate 5 squared plus 12 squared is equal to x squared. Now to solve for x, I'm going to simplify the left-hand side by squaring each of these numbers and achieving a 25 and a 144. I'm then going to add those together. 25 plus 144 is going to be 169. And now I'm left with x squared equal to 169. And so in order to get x by itself, I need to remove that exponent of 2, which is sometimes referred to as a square. And so I need to do the inverse of that, which is going to be to square root. So I'm going to square root both sides. On the right-hand side, I'm now just left with x. And if I use my calculator, the square root of 169 is going to be 13. And so I know that the length of that hypotenuse is 13. Looking at another example here, I want to find the unknown side. That unknown side happens to be the hypotenuse again, and it also asks me to round my answer to the nearest tenth. So, label the triangle again. Always start with your hypotenuse. It does not matter which side is A and B after that, so I'm going to change it from what I did in the last example. I'm going to copy down my formula for Pythagorean Theorem. I'm going to sub in my values of A, B, and C. I'm then going to simplify the left-hand side by squaring 4, squaring 8. I'm then going to add those together to get 80. And then I'm going to square root both sides to get rid of the square on the z, and I will get that z is equal to 8.944. I want to round to the nearest tenth position, which is the first decimal after the decimal point. So therefore, I'm going to use the second position, which is 4. 4 is less than 5, and so that 9 is not going to round up, and I'm going to be left with a final answer of z equaling 8.9. If you want to see a video on rounding, up in the right-hand corner you can see a link to one of my videos on rounding. Now, the other thing you can be asked to do in a Pythagorean Theorem calculation is solve for one of the legs. And so it says solve for the unknown side of x here and round your answer to 2 decimal places. So again, to be consistent, I'm going to label my hypotenuse. My other two sides are just A and B. It does not matter which side is which. I'm going to copy down the Pythagorean Theorem formula and substitute in my values. Now I'm going to square all of the numbers that I can. 9 squared is going to be 81, and then we have x squared, and then 17 squared is going to be 289. Now I want to get x squared all by itself. It was by itself in the previous examples where we were solving for the hypotenuse, But when you solve for a leg, it's not. And so I need to get rid of this 81. And I ask myself, how is 81 connected to the x squared? It's connected via an addition, and so I need to subtract an 81 from each side. On the left-hand side, I'll then be just left with x squared, and on the right-hand side, 289 subtract 81 is going to be 208. I then square root each side to get x by itself. And because I need to round to 2 decimal places, I'm going to take a few extra decimal places here. So this is going to be 14.222. I want to round to the second decimal place because I want 2 decimal places. So I'm going to look at the 2 that's after that. That's under a 5. So therefore, I'm not going to round up. And my final answer is going to be 14.22. One last example here. We're going to solve for the unknown side and round my answer to 2 decimal places again. So I start off by labeling the hypotenuse. My other 2 legs, I'm going to just label A and B. Copy down my Pythagorean Theorem formula. Substitute my values of A, B, and C in. Then I'm going to evaluate the 14 squared and the 21 squared. I then need to get the r squared by itself, so I need to remove this 196. The 196 is connected via addition, so I'm going to subtract 196 from both sides. When I do that, I will get 441 subtract 196. That's going to be an r squared on the left-hand side of the equation and a 245 on the right. In order to isolate for r again, I'm going to square root both sides. Because I want to take 2 decimal places in my final answer, I'm going to take a few extra decimal places. This is going to be 15.6524. I want to round to the second decimal place, so I'm going to look at the decimal place directly after. It's less than 5, therefore I'm not going to round up to the next, and my value of r is 15.65.